What if I told you that in 2017 humanity received its first confirmed visitor from another star system, and we almost missed it completely? This mysterious object, traveling at 26 kilometers per second, defied every law of physics we thought we understood, accelerating away from the sun without any visible explanation. Here's the mind-blowing part. Some of the world's top scientists now believe we may have just witnessed our first encounter with alien technology. Did you know that Oumuamua is still the only confirmed interstellar object we've ever detected, and it's already gone forever? Oumuamua initial detection. On October 19, 2017, the universe delivered humanity its first confirmed interstellar messenger, and it caught us completely off guard. The Pan-STARRS telescope in Hawaii was conducting routine asteroid surveys when astronomers Robert Warwick and his team spotted something extraordinary streaking across the starfield at unprecedented velocity. This wasn't just another space rock cataloged in their database. It was moving too fast, coming from the wrong direction, and following a trajectory that immediately screamed outsider to anyone familiar with solar system dynamics. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first, recognizing that this discovery would fundamentally change our understanding of what lurks in the spaces between stars. Within hours of the initial detection, telescopes around the world were frantically tracking this mysterious visitor as it hurtled past Earth at 26 kilometers per second, speeds that dwarfed anything gravitationally bound to our sun. The object had already completed its closest approach to our star and was racing toward the outer solar system, giving scientists only a precious few weeks to study it before it vanished forever into the cosmic void. What made this discovery truly groundbreaking wasn't just that Oumuamua came from another star system, it was the first interstellar object ever detected passing through our cosmic neighborhood, opening an entirely new field of astronomy and raising profound questions about what else might be drifting silently through the galaxy, undetected by our current observation methods. Classification challenges. The moment scientists began analyzing Oumuamua's properties in detail, they realized they were dealing with something that defied every classification system developed over centuries of astronomical observation. Initially tagged as Asteroid A/2017 U1 based on preliminary observations, the object quickly demonstrated characteristics that challenged this hasty designation. Unlike typical asteroids which maintain relatively stable brightness patterns as they rotate, Oumuamua's luminosity varied dramatically by a factor of 10 as it tumbled chaotically through space, suggesting an extremely unusual elongated shape that was unprecedented in solar system astronomy. Even more puzzling, despite approaching within 0.25 astronomical units of the Sun, close enough to vaporize surface materials on most comets, it displayed absolutely no coma, tail, or any other signs of outgassing that should accompany such solar heating. NASA's Jet Propulsion Laboratory and international astronomy teams spent months in heated debates, frantically analyzing spectroscopic data and photometric measurements while flip-flopping between asteroid and comet classifications as new observations contradicted previous assumptions. The confusion reached such levels that by 2018, the International Astronomical Union was forced to create an entirely new category, officially designating it 1I/Oumuamua, the 1I indicating the first confirmed interstellar object, and establishing a new nomenclature system for future discoveries. This classification nightmare highlighted how woefully unprepared our taxonomic systems were for objects originating beyond our solar system, forcing the scientific community to acknowledge that Oumuamua might represent a completely unknown class of celestial bodies formed under conditions and processes entirely different from anything occurring within our sun's gravitational influence. Trajectory analysis. When astronomers reverse-engineered Oumuamua's cosmic journey using sophisticated orbital mechanics calculations, they uncovered an epic tale spanning potentially millions of years across the vast emptiness of interstellar space. The comprehensive trajectory analysis performed by international teams at ESA's European Space Operations Center and NASA's Jet Propulsion Laboratory revealed that this interstellar wanderer had been drifting through the galaxy long before our solar system had even settled into its current configuration of planets and orbital resonances. Using precise astrometric measurements from multiple observatories, Researchers initially calculated that tracing its path backward pointed toward the direction of Vega in the constellation Lyra, one of the brightest stars in our night sky. However, deeper analysis incorporating proper motion corrections and galactic rotation models revealed a far more complex story that challenged simple origin theories. The object would have needed approximately 600,000 years to travel from Vega's current position to reach our solar system, yet stellar motion calculations proved that Vega wasn't located in that position 600 millennia ago due to the constant movement of stars through galactic space. This startling discovery proved that Oumuamua was a true galactic nomad with no clear stellar home, having wandered through multiple stellar neighborhoods during its cosmic odyssey. Its hyperbolic trajectory, a mathematically defined path that curves around the Sun once before heading back to interstellar space forever, indicated approach speeds of 44 kilometers per second relative to our Sun at perihelion. Unlike the elliptical orbits of comets and asteroids gravitationally bound to our star, Oumuamua possessed more than enough kinetic energy to escape permanently into the cosmic wilderness, never to return to our solar system again. Photometry and shape analysis. The light measurements of Oumuamua revealed, honestly, the most bizarre shape ever recorded for any natural object in our solar system. Photometric observations conducted by observatories all over the globe, including the Very Large Telescope in Chile and Gemini Observatory in Hawaii, showed brightness variations that, well, could only be explained by an extremely elongated form. Scientists calculated that Oumuamua was at least 10 times longer than it was wide, with dimensions roughly 400 meters by 40 meters, kind of resembling a cosmic cigar tumbling end over end through space. Dr. Karen Meach from the University of Hawaii led international teams analyzing these light curves, discovering the object completed one full rotation every 7.3 hours. The extreme aspect ratio was totally unprecedented. No known asteroid or comet even came close to such proportions. Some researchers, including Dr. Shmuel Bieli, proposed it might be even flatter, resembling a cosmic pancake rather than a cigar, which honestly would make it even more unusual. The surface appeared reddish, similar to objects in the outer solar system that have been darkened by cosmic radiation over billions of years. However, Oumuamua reflected only about 4% of incident sunlight, making it darker than charcoal. This combination of extreme elongation, dark surface, and rapid tumbling motion created a unique signature that really challenged existing models of how small bodies form and evolve in space, suggesting formation processes completely unlike anything occurring in our solar system. Acceleration anomaly. The discovery that, honestly, shattered every conventional explanation came when precise tracking revealed Oumuamua was accelerating away from the Sun in ways that just defied physics. Dr. Marco Michelli and his international team published their groundbreaking findings in Nature journal in June 2018, documenting a small but measurable non-gravitational acceleration of approximately 4.92 times 10 to the -6 meters per second squared. This wasn't measurement error. Multiple independent observations confirmed that Oumuamua was actually speeding up as it moved away from our star. For typical comets, acceleration like this makes perfect sense. Frozen gases sublimate near the Sun, creating jets that act like tiny rocket engines. However, Oumuamua showed absolutely no signs of this outgassing activity. No visible coma, no tail, no gas emissions detectable by any instrument. The Hubble Space Telescope conducted follow-up observations that confirmed the anomalous motion while ruling out systematic errors or unknown forces. This acceleration was too large to be explained by solar radiation pressure alone, yet too small to be caused by gravitational influences from planets or other bodies. The mystery deepened when scientists realized that whatever was causing this acceleration appeared to be acting continuously and smoothly, rather than in bursts typical of comet outgassing. This unprecedented behavior forced astronomers to consider possibilities they had never seriously contemplated. Either Oumuamua represented a completely unknown type of natural phenomenon, or, well, something artificial was responsible for its strange motion through our solar system. Spitzer observations. NASA's Spitzer Space Telescope conducted humanity's final attempt to solve the Oumuamua mystery before the object disappeared forever beyond the reach of Earth's instruments. During November 2017, this infrared observatory pushed its capabilities to the absolute limit. conducting some of the most sensitive thermal measurements ever attempted on such a distant small object. Dr. Davide Farnocchia and his team at JPL analyzed the resulting data, hoping to detect the warm signatures of outgassing that might explain the acceleration anomaly. Instead, Spitzer's observations only deepened the puzzle. The telescope detected virtually no thermal emission from Oumuamua, setting strict upper limits on any dust or gas production. If the object were behaving like a normal comet, even minimal outgassing should have created detectable infrared signatures, as solar heating warmed expelled material. The absence of such emissions meant that if outgassing was responsible for the acceleration, it had to be composed of materials completely invisible to infrared detection. Spitzer's measurements also refined estimates of Oumuamua's size and reflectivity, suggesting it was smaller than initially calculated, possibly only 100 to 200 meters in its longest dimension. This smaller size would actually amplify any outgassing effects, making the lack of detectable emissions even more mysterious. The final Spitzer observations in January 2018 showed Oumuamua continuing its anomalous acceleration while remaining thermally invisible, leading scientists to conclude that conventional comet behavior could not explain this object's properties and motion through our solar system. Artificial origin hypothesis. When every natural explanation failed, Harvard University's Professor Avi Loeb and postdoctoral researcher Shmuel Bialy proposed the unthinkable in a paper published in the Astrophysical Journal Letters in October 2018. They suggested that Oumuamua might actually be artificial, specifically a light sail created by an extraterrestrial civilization. This hypothesis, honestly, elegantly explained the acceleration anomaly. A thin, flat object could be pushed by solar radiation pressure without requiring any outgassing. For this mechanism to work, Oumuamua would need to be incredibly thin, less than 1 millimeter thick, while still maintaining its observed dimensions. Loeb proposed it could be debris from alien technology, possibly millions of years old, just drifting through space like cosmic junk from a long-dead civilization. The light sail hypothesis explained not only the non-gravitational acceleration, but also the object's extreme elongation and its unusual tumbling motion. Dr. Loeb argued that extraordinary claims require extraordinary evidence, but, extraordinary evidence also requires extraordinary hypotheses. The scientific establishment reacted with fierce criticism, with many astronomers arguing that invoking alien technology violated Occam's razor, the principle favoring simpler explanations. However, supporters pointed out that dismissing the possibility without proper investigation could actually represent a form of cosmic prejudice. The debate raged across scientific journals and conferences, with researchers split between those demanding more conventional explanations and others willing to consider that humanity had encountered its first piece of alien technology, even if we couldn't definitively prove it. Dark comet theory. Dr. Daryl Seligman from the University of Chicago proposed a revolutionary alternative that really challenged our understanding of comet composition and interstellar chemistry. The dark comet hypothesis, which was published in the Astrophysical Journal back in 2020, suggested that Oumuamua could actually be made mostly of frozen molecular hydrogen. In the extreme cold of interstellar space, where temperatures are around 14 Kelvin, hydrogen can freeze into solid ice that would stay stable for millions of years. As Oumuamua got closer to our sun, this hydrogen ice would sublimate directly into gas, but unlike water vapor or other typical comet materials, hydrogen gas is almost completely invisible to most astronomical instruments. This invisible outgassing could explain the mysterious acceleration without creating any visible coma or tail. The theory goes on to suggest that Oumuamua formed billions of years ago in a giant molecular cloud. Those vast regions of space where gas and dust come together before forming new stars and planetary systems. These environments could create really unique conditions for hydrogen ice to build up, making objects unlike anything we've seen in our own solar system. Seligman's calculations showed that a hydrogen iceberg about the size of Oumuamua could stay intact during its journey through interstellar space, and provide enough outgassing to explain the observed acceleration. This hypothesis opened up the possibility of an entirely new class of interstellar objects that might be drifting undetected all over the galaxy, basically invisible to our current observation methods, because their outgassing doesn't produce any visible signatures that our telescopes can pick up. Dark comet classification. The implications of the dark comet theory went way beyond just Oumuamua. It could totally revolutionize the way astronomers classify small bodies in space. Researchers at NASA's Jet Propulsion Laboratory started developing new classification systems to account for objects that show non-gravitational acceleration, but without any visible activity. Scientists began to propose distinguishing between small dark comets like Oumuamua, which came from interstellar space, and potentially large dark comets that might actually exist within our own solar system, just unrecognized up until now. Dr. Daryl Seligman and his colleagues even identified several objects in the solar system database that showed unexplained acceleration without obvious outgassing, suggesting that dark comets might be way more common than we ever imagined. The new classification parameters included things like thermal emission signatures, spectroscopic properties, and acceleration magnitudes that are really different from what we see with traditional comets and asteroids. This new framework suggested that maybe our telescopes have been missing a whole population of hydrogen-rich objects simply because our detection methods are tuned for water-ice comets and rocky asteroids. The European Space Agency even started to include dark comet detection protocols in their future mission planning, realizing that interstellar visitors could be a lot more common than just the single confirmed case of Oumuamua. Some researchers estimated that if the dark comet hypothesis is correct, the galaxy could have billions of these invisible objects, creating a hidden population of interstellar wanderers that occasionally pass through planetary systems without us even noticing. This whole idea really changes our understanding of how material is distributed across the galaxy, and it suggests that the space between stars could be way more crowded with small bodies than our astronomical models had predicted. Scientific debate. The Oumuamua controversy has basically split the astronomical community into competing camps, each one defending some pretty radically different interpretations of the same data. Team Natural, led by researchers at NASA's Goddard Space Flight Center and the European Southern Observatory, insists that conventional physics has to explain the acceleration anomaly, and they propose things like outgassing of common volatiles or internal changes during solar heating. Then there's Team Artificial, led by Harvard's Avi Loeb and backed by researchers from Tel Aviv University, who argue that the light sail hypothesis deserves serious scientific consideration, and shouldn't just be dismissed because people are skeptical about extraterrestrial explanations. Team Dark Comet, centered around researchers at the University of Chicago and Yale University, is pushing the hydrogen iceberg theory and working on ways to detect similar objects. The debate has been going strong in top scientific journals like Nature, Science, and the Astrophysical Journal since 2018, and honestly, each new analysis seems to make the mystery even deeper. Dr. Alan Fitzsimmons from Queen's University Belfast leads the skeptics, saying that these exotic explanations go against scientific principles, while Dr. Abraham Loeb's supporters counter that extraordinary evidence demands extraordinary hypotheses. Recent studies have even found more solar system objects with similar properties, which could support the dark comet classification. The scientific process is working exactly as it should. Competing hypotheses are driving new observations and new theories. Whether Oumuamua was natural, artificial, or something totally unprecedented, it's already changed astronomy by showing that interstellar objects can really challenge our most basic assumptions about the universe, forcing scientists to broaden their frameworks for understanding cosmic phenomena. So, there you have it. Oumuamua is still one of the greatest mysteries in modern astronomy, challenging just about everything we thought we knew about interstellar objects. Whether it was a natural dark comet, alien technology, or something completely unprecedented, this cosmic visitor has forever changed the way we see our place in the universe. What's your theory? Was Oumuamua our first glimpse of extraterrestrial engineering, or does nature still have more surprises up its sleeve? Drop your thoughts in the comments below. I read every single one. And if you're fascinated by these mind-bending space mysteries, go ahead and smash that subscribe button and hit the bell icon so you never miss the latest discoveries from InnoVision Tech. Until next time, keep looking up. Imagine looking up at the night sky and realizing that something from another star system is silently racing past us at incredible speed. In the summer of 2025, astronomers detected exactly that. A mysterious visitor from the depths of interstellar space that has been traveling for millions of years before finally reaching our solar system. This cosmic wanderer, known as 3I Atlas, represents only the third confirmed interstellar object ever discovered. Today we'll explore everything scientists have learned about this extraordinary celestial traveler and what it reveals about our galaxy. Discovery of 3I Atlas. Here's the moment that changed our understanding of interstellar visitors forever. On July 1, 2025, the Atlas telescope system at Rio Hurtado Observatory in Chile captured images of an unusual moving object racing through space at 61 kilometers per second. The Discovery team, led by Larry Deneau from the University of Hawaii's Institute for Astronomy, immediately recognized that this wasn't an ordinary asteroid or comet from our solar system. The object's hyperbolic trajectory and extreme velocity indicated it was following an escape path from our sun's gravitational influence. Initially catalogued as A11PL3Z, the mysterious visitor was positioned 4.5 astronomical units from the sun, approaching from the direction of Sagittarius. What made this detection particularly remarkable was that pre-discovery images dating back to June 14, 2025, revealed the object had been approaching undetected for weeks. The reason for this delayed discovery was its trajectory through the dense star fields near our galaxy's center, where countless background stars made it nearly impossible to spot against the crowded stellar backdrop. Within hours of confirmation, observatories worldwide began tracking this rare interstellar wanderer, setting the stage for one of astronomy's most significant discoveries. Atlas Survey System. But here's where this discovery became truly historic and earned its place in astronomical records. After extensive trajectory analysis by the Minor Planet Center, the object received its official designation as 3Y Atlas, where 3I signifies it as the third confirmed interstellar object in human history. This places it alongside the famous 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019. However, 3I Atlas quickly distinguished itself from its predecessors in a remarkable way. Karen Meach from the University of Hawaii and her international team confirmed on July 2, 2025, that the object was displaying clear cometary activity. Unlike Oumuamua, which remained enigmatically inactive throughout its visit, 3Y Atlas developed a visible coma and tail almost immediately after discovery. Observations from the Nordic Optical Telescope revealed the comet was clearly active with a distinctive tail measuring at least 25,000 kilometers in length. John Tonry, principal investigator of the Atlas project, noted that this discovery validated their sky survey system's capability to detect rare astronomical phenomena. The rapid identification of cometary activity made 3Y Atlas the second confirmed interstellar comet, providing scientists with an unprecedented opportunity to study active sublimation processes in a visitor from another star system. Object classification and naming. Now prepare to be amazed by the sheer scale of this interstellar giant. Recent observations conducted by Marco Micheli from the European Space Agency using the Vera C. Rubin Observatory have determined that 3Y Atlas measures approximately 11.2 kilometers in diameter, making it significantly larger than both previous interstellar visitors combined. This massive size has profound implications for scientific study, as larger objects retain more of their original composition and provide clearer observational targets for detailed analysis. The comet's substantial nucleus is surrounded by an active coma that exhibits a distinctly reddish coloration, remarkably similar to what was observed in 2I Borisov. Daryl Seligman from Michigan State University, who led the initial characterization studies, noted that this color similarity suggests interstellar comets may share common compositional characteristics regardless of their stellar origin. The impressive scale of 3Y Atlas means it will remain visible to Earth-based telescopes for an extended period, giving researchers months rather than weeks to conduct comprehensive observations. This extended visibility window represents a golden opportunity for the astronomical community to gather unprecedented data about interstellar comet composition, structure, and behavior as it interacts with our sun's radiation and solar wind during its passage through our solar system. Orbital characteristics. Okay, here's something that will really blow your mind about this cosmic time capsule's incredible journey through space. Based on detailed orbital mechanics calculations performed by Davide Farnochia at NASA's Jet Propulsion Laboratory, scientists believe that 3I/Atlas actually originated from the Milky Way's thick disk region, where ancient stellar populations reside. This means the comet is potentially around 7 billion years old, which is, well, older than our entire solar system by approximately 2.5 billion years. Its epic journey likely began when gravitational perturbations from massive planets or maybe even close stellar encounters ejected it from its birth star system eons ago. For millions of years, this ancient wanderer drifted through the frigid vacuum of interstellar space at temperatures approaching absolute zero, which honestly perfectly preserved its primordial composition like a cosmic freezer. Sam Dean, an amateur astronomer who helped identify additional pre-discovery observations, contributed to tracking the comet's path backwards through time. The comet's trajectory suggests it has been traveling through the galaxy's spiral arms, potentially witnessing the formation and destruction of countless star systems during its incredible voyage. This preservation makes 3I/Atlas an invaluable scientific specimen, carrying within its frozen nucleus the chemical signatures and formation conditions that existed in a distant star system billions of years ago, offering unprecedented insights into galactic evolution and early planetary system formation processes. Physical properties. But here's what makes this discovery even more extraordinary: the unprecedented international scientific collaboration that made it possible. The research effort was spearheaded by Michigan State University's Daryl Seligman, who coordinated with a global network of observatories and research institutions to maximize observation time and data quality. Robert Warwick from the University of Western Ontario, who previously discovered 1I Oumuamua, provided crucial expertise in interstellar object identification and tracking protocols. The collaborative team included researchers from the European Southern Observatory, NASA's Goddard Space Flight Center, and the Harvard-Smithsonian Center for Astrophysics, really demonstrating how modern astronomy relies on rapid international cooperation. Grigory Fedoretz from Queen's University Belfast contributed orbital dynamics expertise, while Tony Farnham from the University of Maryland provided cometary activity analysis. This coordinated effort represents one of the most comprehensive rapid response campaigns in astronomical history, with over 50 professional observatories and numerous amateur astronomers contributing observations within the first month of discovery. The team's ability to quickly organize this global response ensured that critical early observations were captured before the comet's activity levels changed, maximizing the scientific return from this rare interstellar visitor and establishing new protocols for future interstellar object studies. Comet activity features. Now let's trace the incredible path this ancient wanderer will take through our solar system over the coming months. 3I/Atlas will reach its closest approach to the Sun, called perihelion, on October 29, 2025, at precisely 11:41 Universal Time. At this crucial moment, it will be positioned 1.36 astronomical units from the Sun, that's about 203 million kilometers away, perfectly situated between the orbits of Earth and Mars. This optimal distance means the comet will experience significant heating without being destroyed by extreme solar radiation. During its approach phase, the comet will have several notable planetary encounters that provide unique observational opportunities. On October 3, 2025, it will pass just 0.19 astronomical units from Mars, only 28 million kilometers away, potentially allowing Mars-based instruments to conduct close-range observations. Following perihelion, the comet will swing past Venus on November 3, 2025 at a distance of 0.65 astronomical units. Most importantly for Earth-based observers, our planet remains completely safe throughout this cosmic dance. The closest 3I/Atlas will approach Earth is 1.8 astronomical units on December 19, 2025. That's about 270 million kilometers away, providing excellent viewing conditions while maintaining a comfortable safety margin. This trajectory offers astronomers multiple observation windows from different vantage points throughout the solar system. Amateur contributions. Here's where the scientific excitement reaches its peak: the detailed analysis of this interstellar visitor's composition and structure. Spectroscopic observations conducted by Alan Fitzsimmons from Queen's University Belfast using the Gemini Observatory have revealed that 3Y Atlas is composed primarily of water ice, silicate minerals and organic compounds similar to comets in our own solar system. However, The presence of exotic isotopic ratios in its gas emissions suggests formation conditions significantly different from our local environment. Bin Yang from the European Southern Observatory detected unusual concentrations of deuterium-rich water vapor, indicating the comet formed in an extremely cold environment around a different type of star. As the comet approaches the Sun, increasing solar radiation is causing accelerated sublimation of volatile ices, revealing deeper layers that have remained frozen for billions of years. Jacqueline Keene from Boston University has identified traces of carbon monoxide and methane in the comet's tail, providing insights into the chemical conditions of its birth star system. The James Webb Space Telescope, under observations led by Stephanie Malam from NASA Goddard, has been scheduled to conduct detailed infrared spectroscopy to identify complex organic molecules that might exist within the comet's nucleus. These compositional studies are providing unprecedented insights into star formation processes and the distribution of life-building molecules throughout our galaxy. Surface composition. But here's what makes this observation campaign truly revolutionary: the unprecedented coordination of space-based and ground-based telescopes working together. Paul Chodas from NASA's Center for Near-Earth Object Studies has coordinated orbital predictions that allow telescopes to track the comet with extreme precision. The Hubble Space Telescope, under the direction of Matthew Knight from the Naval Research Laboratory, captured high-resolution images on July 21, 2025 that revealed intricate details of the comet's coma structure and dust distribution patterns. Ground-based facilities including the Very Large Telescope in Chile and the Keck Observatory in Hawaii have been providing continuous monitoring of the comet's brightness changes and spectral evolution. Quanzi Ye, from the University of Maryland, has been leading photometric studies that track how the comet's activity levels change as it approaches the Sun. The NEOWISE Space Telescope has been measuring infrared emissions to determine the comet's temperature distribution and internal heat sources. This coordinated campaign represents the most comprehensive study of an interstellar object ever conducted, with data collection continuing through September 2025, before the comet passes too close to the Sun for safe observation. The wealth of data being collected will provide material for scientific studies for decades to come, advancing our understanding of interstellar chemistry and planetary system formation processes. Interstellar object density. Now here's something that sounds like science fiction but is being seriously considered by space agencies worldwide. Atsuhiro Yaginuma, an undergraduate researcher working with Daryl Seligman at Michigan State University, is conducting detailed trajectory analysis to determine whether a rapid spacecraft mission to 3Y Atlas might be feasible. The challenge is enormous. Intercepting an object moving at 61 kilometers per second would require unprecedented propulsion technology and launch timing precision. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory has been evaluating existing spacecraft designs that could potentially reach the comet during its closest approach to Earth in December 2025. Such a mission would need to launch within months of the discovery, requiring massive international cooperation and emergency mobilization of space resources. Alan Stern, principal investigator of the New Horizons mission, noted that while technically challenging, the scientific payoff from getting close to an interstellar object would be revolutionary. A successful intercept could provide direct samples of materials from another star system, potentially containing organic compounds or even microscopic signs of extraterrestrial life. Even if a full intercept proves impossible, the research being conducted is advancing rapid response space mission capabilities and establishing protocols for future interstellar object encounters. The mere possibility represents a remarkable leap in humanity's ability to explore beyond our solar system. Origins and age speculation. Finally, here's the most profound implication of this discovery for the future of astronomy and our understanding of the cosmos. The detection of 3I Atlas, following Oumuamua and Borisov, is providing statistical evidence that interstellar objects are far more common than previously estimated. Mark Norris, from the University of Central Lancashire, has calculated that approximately one interstellar object larger than 100 meters passes through our solar system every year, though most remain undetected. Robert Jedicke from the University of Hawaii estimates that the Atlas survey system, with telescopes in Hawaii, Chile, and South Africa, will detect several interstellar objects annually as technology improves. The Vera Rubin Observatory, scheduled to begin full operations in 2025, is expected to revolutionize interstellar object discovery with its ability to scan the entire visible sky every few nights. Michelle Bannister from the University of Canterbury predicts that within a decade, we'll have discovered dozens of these cosmic wanderers, providing a statistical sample large enough to understand galactic dynamics and planetary system evolution. Each new discovery adds pieces to the puzzle of how materials and potentially life itself might be distributed throughout our galaxy. 3. I-Atlas isn't just a single remarkable discovery, it's opening an entirely new field of astronomy that studies the messengers traveling between star systems, carrying secrets from across the galaxy. From its ancient origins in the thick disk of our galaxy to its spectacular journey past our sun, 3I-Atlas has revolutionized our understanding of interstellar visitors and the materials that travel between star systems. This cosmic time capsule, preserved for billions of years in the cold of space, continues to reveal secrets about distant worlds and the formation of our galaxy itself. As we track its departure back to interstellar space, we can only wonder what other mysteries await discovery. Like, share, and subscribe to InnoVision Tech for more cosmic revelation. What if the mysterious object racing through our solar system isn't what it appears to be? Fresh observations of 3I/Atlas are revealing characteristics so unusual that some scientists are questioning whether we're dealing with a natural comet at all. This interstellar visitor's trajectory, timing, and behavior patterns are defying conventional explanations, leading to heated debates in the scientific community. Today, we'll examine the mounting evidence that suggests this cosmic wanderer might be far more extraordinary than anyone initially imagined, and explore the controversial possibility that we could be witnessing something truly unprecedented. Discovery and initial detection. The story of 3I/Atlas begins with a routine sky survey that would soon turn extraordinary. On July 1, 2025, the Atlas telescope system at Rio Hurtado Observatory in Chile captured images of an unusual fast-moving object designated A11PL3Z. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object. Within days, follow-up observations confirmed what astronomers had suspected. This was the third confirmed interstellar visitor in human history, joining the ranks of 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019. The object received multiple designations, 3I-Atlas for its interstellar status, and C2025N1 for its cometary characteristics. What made this discovery particularly intriguing was that despite entering our solar system weeks earlier, 3I-Atlas had remained undetected due to its challenging viewing angle against the dense star fields near Sagittarius. John Tonry, principal investigator of the Atlas project, noted that pre-discovery images dating back to June 14, 2025 revealed the object had been silently approaching our solar system for an extended period. This late detection would prove to be just the first of many unusual characteristics that would set 3I-Atlas apart from any cosmic visitor we'd ever encountered. Extraordinary orbital characteristics. Prepare to have your mind blown by the absolutely extraordinary orbital mechanics of this interstellar wanderer. Davide Farnocchia from NASA's Jet Propulsion Laboratory has calculated that 3I-Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest value ever recorded for any known interstellar object. This mathematical measurement indicates just how dramatically different this visitor's path is from anything bound to our solar system. Even more remarkable is its incoming velocity of 58 kilometers per second, making it the fastest interstellar visitor ever recorded approaching our cosmic neighborhood. But here's where things get truly suspicious. The trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun. Marco Micheli from the European Space Agency has calculated that the probability of this alignment occurring by random chance is merely 0.2%. This isn't just unusual, it's astronomically improbable. Most objects from interstellar space would approach from random angles, yet 3I-Atlas chose a path that seems almost deliberately designed for optimal planetary encounters. The precision of this trajectory has prompted some researchers to question whether we're witnessing natural celestial mechanics or something far more intentional. Such mathematical precision in cosmic trajectories typically requires either extraordinary coincidence or deliberate planning. suspicious planetary encounters. The planetary encounter sequence of 3I Atlas reads like a carefully choreographed cosmic ballet that defies statistical probability. Robert Warwick from the University of Western Ontario, who previously discovered Oumuamua, has analyzed the object's path and found it passes unusually close to Venus, Mars, and Jupiter during its solar system transit. The probability of such close encounters occurring randomly has been calculated at an astounding 0.005%. Essentially impossible by chance alone. But the timing gets even more suspicious. Paul Chodas from NASA's Center for Near-Earth Object Studies has determined that 3I Atlas reaches its closest approach to the Sun precisely when Earth would be positioned on the opposite side, blocking direct observation during the most critical phase of its visit. The statistical probability of this alignment? A mere 7% chance. Karen Meach from the University of Hawaii has noted that rather than resembling the chaotic path of a randomly ejected comet, the trajectory appears optimized for studying the inner solar system planets while minimizing detection risks. This orbital choreography provides optimal vantage points for comprehensive planetary observations, exactly what you'd expect from a reconnaissance mission rather than a chance cosmic encounter. The mathematical precision required for such a trajectory suggests either unprecedented natural coincidence or deliberate design by an intelligence capable of interplanetary navigation. Physical properties and anomalies. The physical characteristics of 3I/Atlas are equally perplexing and honestly challenge our understanding of typical interstellar objects. Daryl Seligman from Michigan State University has determined that the object measures somewhere between 1 to 12 kilometers in diameter, making it significantly larger than both previous interstellar visitors and providing an unprecedented opportunity for detailed study. Spectroscopic analysis suggests this cosmic wanderer is extraordinarily ancient, potentially 7 billion years old, predating our entire solar system by billions of years. This makes it a genuine cosmic fossil, carrying secrets from the early epochs of our galaxy. Quanzi Ye from the University of Maryland has confirmed that 3I/Atlas is the brightest interstellar object ever observed, allowing for detailed spectroscopic analysis that just wasn't possible with previous visitors. Perhaps most intriguingly, the object exhibits a 29-hour rotation period with minimal brightness variation, suggesting either a spherical shape or a uniform surface composition, characteristics that are pretty unusual for natural comets. Matthew Knight from the Naval Research Laboratory has noted that high-resolution observations reveal a remarkably compact and dense appearance, lacking the typical fuzzy, diffuse structure expected from ancient comets. These physical properties suggest either an unusually well-preserved natural object or something with a fundamentally different composition and structure than anything we've previously encountered in our solar system. Comet-like features versus anomalous behavior. Here's where 3I/Atlas becomes truly enigmatic. It displays some comet-like characteristics while simultaneously exhibiting behavior that frankly just defies cometary physics. Alan Fitzsimmons from Queen's University Belfast has confirmed that the object shows a faint coma and a short tail measuring approximately 3 arc-seconds, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations have detected the characteristic signature of sublimating water ice, producing the dust and gas envelope typical of approaching comets. However, Tony Farnham from the University of Maryland has noted several anomalies that challenge this interpretation. Despite its proximity to the Sun and evidence of outgassing, 3I/Atlas maintains a remarkably compact, dense appearance that differs dramatically from the fuzzy, diffuse structure of typical comets. Most puzzling is the absence of an expected extended tail, which really should be prominent given the object's size and solar distance. Bin Yang from the European Southern Observatory has observed that the outgassing patterns don't follow standard cometary models, with irregular brightness variations that suggest complex subsurface processes. The combination of active sublimation with maintained structural integrity presents a paradox. How can an object simultaneously behave like a comet while retaining characteristics more consistent with a solid engineered structure? This contradiction has sparked intense debate about whether we're observing natural cometary processes or something fundamentally different masquerading as a comet. Scientific debate, natural versus artificial. The scientific community has erupted into heated debate over the true nature of 3I/Atlas, with interpretations ranging from exotic natural phenomena to, well, potentially artificial origins. Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard University, has emerged as the most vocal proponent of considering artificial origins, pointing to the statistically improbable trajectory and suspicious timing as evidence that, in his view, warrants serious investigation. Loeb argues that the mathematical precision of the object's path, combined with its optimal positioning for planetary reconnaissance, exceeds reasonable expectations for random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide. However, mainstream astronomers have pushed back strongly against these suggestions. Sarah Seeger from MIT acknowledges the unusual characteristics while emphasizing the importance of exhausting natural explanations before considering extraordinary possibilities. Robert Yedecke from the University of Hawaii has criticized speculation about artificial origins as premature and potentially damaging to scientific credibility. The debate highlights fundamental questions about how we interpret anomalous data and the threshold of evidence required for paradigm-shifting discoveries. Alan Stern, principal investigator of the New Horizons mission, has noted that while the characteristics are unusual, the universe is full of phenomena that initially appear impossible until we develop a better understanding of the underlying physics. Spectral analysis mysteries. The spectroscopic data from 3I/Atlas is revealing some puzzling inconsistencies that are, honestly, challenging our understanding of interstellar object composition. Stephanie Malam from NASA Goddard Space Flight Center has been coordinating observations using the James Webb Space Telescope to conduct detailed infrared spectroscopy of the object's composition. Initial results confirm the presence of water-ice spectrum, but the patterns just don't match our expected models. Jacqueline Keene from Boston University has identified these anomalous spectral signatures, where the observed signals actually increase in regions where water-ice models predict they should decrease. This contradiction suggests either unknown compositional elements or maybe structural properties that don't conform to standard cometary models. Now the object exhibits a distinctly reddish coloration, similar to objects in our outer asteroid belt, yet its interstellar origin kind of rules out formation in our solar system. Michelle Bannister from the University of Canterbury has noted that attempts to determine precise composition are complicated by the active coma surrounding the nucleus, which creates interference in spectral measurements. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory has suggested that these unusual spectral characteristics might indicate exotic ice compositions or internal structures not found in solar system objects. So, these spectroscopic mysteries really add another layer of intrigue to an already enigmatic visitor, suggesting that 3I/Atlas may be composed of materials or structured in ways we just don't yet understand. Dark forest hypothesis implications. The behavior patterns of 3I/Atlas align remarkably well with theoretical models of how an advanced civilization might conduct reconnaissance while avoiding detection. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that intelligent civilizations remain hidden to avoid potential threats from other species. Seth Shostak from the SETI Institute has noted that 3I/Atlas exhibits what could be interpreted as stealth-like behavior, deliberately timing its closest solar approach when Earth would be positioned to block optimal observation. This timing ensures that the most detailed study phase occurs when our planet's scientific instruments have limited access to the visitor. Jill Tarter, former director of SETI research, has observed that the trajectory allows for comprehensive surveying of inner solar system planets, while minimizing exposure to potential detection by any resident intelligence. The orbital path provides optimal vantage points for studying Earth's atmosphere, Mars's surface conditions, and Venus's cloud dynamics, exactly the type of data an exploring civilization would prioritize. Frank Drake, creator of the famous Drake equation, noted before his passing that such reconnaissance patterns would represent logical exploration strategies for risk-averse civilizations. While most scientists remain skeptical of artificial explanations, the behavioral patterns of 3I/Atlas do match theoretical models of how cautious interstellar explorers might operate when encountering potentially inhabited star systems. Historical context and lessons. The discovery of 3I Atlas comes with profound lessons learned from our missed opportunities with previous interstellar visitors. When 1I Oumuamua was discovered in 2017, the scientific community was caught completely unprepared for studying such a rare phenomenon. Robert Warwick, who discovered Oumuamua using the Pan-STARRS 1 telescope, has reflected on how the object's rapid departure left many critical questions unanswered. The mysterious acceleration exhibited by Oumuamua without visible outgassing remains unexplained to this day, highlighting the importance of comprehensive observation campaigns. Gennady Borisov, the amateur astronomer who discovered 2I Borisov in 2019 from his observatory in Crimea, provided the astronomical community with a second chance that was better utilized. However, even Borisov's study was limited by available technology and coordination protocols. Mark Norris, from the University of Central Lancashire, has emphasized that 3I Atlas represents our most comprehensive opportunity yet to properly study an interstellar visitor with advanced instruments and coordinated global observation campaigns. The improved detection capabilities of modern sky surveys, combined with rapid communication networks, have enabled real-time coordination among observatories worldwide. Michelle Bannister has noted that the lessons learned from previous interstellar encounters have fundamentally changed how the astronomical community approaches these rare events, ensuring that we're better prepared to unlock the secrets these cosmic messengers carry from distant star systems. Future observations and implications. The coming months represent a critical window for determining the true nature of 3I Atlas before it departs our solar system forever. Perihelion is scheduled for October 30, 2025, after which the object will begin its journey back toward interstellar space. Paul Chodas has calculated that 3I Atlas will re-emerge from behind the Sun in December 2025, providing a final opportunity for detailed observations before it becomes too distant for meaningful study. Karen Meach is coordinating an unprecedented international observation campaign involving over 50 professional observatories and numerous space-based instruments. The Hubble Space Telescope, James Webb Space Telescope, and ground-based facilities including the Very Large Telescope in Chile are all dedicating precious observation time to this cosmic visitor. Daryl Seligman has noted that the data collected during this campaign will either confirm 3I Atlas as an exotic but natural interstellar comet, or potentially revolutionize our understanding of what's possible in our cosmic neighborhood. The implications extend far beyond pure astronomy. If 3I Atlas proves to be artificial, it would fundamentally alter humanity's perspective on our place in the universe and our approaches to planetary defense and interstellar communication. Alan Fitzsimmons emphasizes that regardless of the final interpretation, 3I Atlas represents a pivotal moment in astronomy, where advanced technology meets unprecedented opportunity to study materials and possibly intelligence from beyond our solar system. As 3I Atlas continues its mysterious journey through our solar system, it challenges everything we thought we knew about interstellar visitors. Whether this ancient wanderer is an exotic natural phenomenon or something far more extraordinary, it's forcing us to expand our understanding of what's possible in the cosmos. The next few months will be crucial in determining the truth about this enigmatic visitor before it disappears back into the depths of space. Stay tuned to InnoVision Tech for the latest updates on this cosmic mystery. Share and subscribe. A mysterious object is racing toward our solar system at incredible speed, and scientists are scrambling to understand what it really is. In the summer of 2025, astronomers made a discovery that has sent shockwaves through the scientific community. A massive visitor from interstellar space that's unlike anything we've ever encountered. Some researchers are asking the unthinkable question: could this be something artificial? Today we'll explore the mind-bending discovery of 3I Atlas and investigate whether we might be witnessing our first contact with alien technology. A rare visitor from deep space. Picture this. You're looking up at the night sky, completely unaware that something extraordinary is racing toward us from the depths of interstellar space at unimaginable speed. In the summer of 2025, astronomers detected exactly that, a massive cosmic wanderer that has been traveling through the galaxy for potentially billions of years before finally entering our solar system. This isn't just any ordinary asteroid or comet from our familiar cosmic neighborhood. This is 3I Atlas, a visitor from another star system entirely, carrying with it secrets from the far reaches of our galaxy that could revolutionize our understanding of how planetary systems form and evolve. What makes this discovery absolutely mind-blowing is that we're witnessing only the third confirmed interstellar object ever detected in human history. The rarity of such encounters means that most of us will never see another visitor like this in our lifetimes. As 3I Atlas races through our solar system at 61 kilometers per second, it's providing scientists with an unprecedented opportunity to study materials that originated around a completely different star, potentially offering our first glimpse into the composition and characteristics of distant worlds we may never be able to visit directly. The breaking discovery. Here's the moment that changed everything we thought we knew about our cosmic neighborhood. The discovery of 3I Atlas represents only the third confirmed interstellar object ever detected passing through our solar system, placing it in an extraordinarily rare category of cosmic visitors. To put this rarity in perspective, astronomers estimate that only one interstellar object larger than 100 meters crosses our solar system annually. Yet most remain completely undetected due to their incredible speed and darkness. Robert Jedicka from the University of Hawaii has calculated that detecting these objects requires perfect timing and cutting-edge technology working in harmony. The significance of 3I Atlas cannot be overstated. It joins the legendary 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019 as the only confirmed messengers from other star systems. What makes this discovery particularly groundbreaking is its massive size and unusual characteristics that are forcing scientists to reconsider their understanding of interstellar objects. Unlike typical asteroids or comets from our solar system, these visitors carry secrets from distant star systems, potentially harboring materials and information that could revolutionize our understanding of planetary formation, galactic evolution, and perhaps even the possibility of life beyond Earth. Each new interstellar detection brings us closer to understanding the true nature of our galaxy's wandering population. The discovery story. The incredible story of how we discovered this cosmic wanderer began in the final days of June 2025, when the Atlas telescope system at Rio Hurtado Observatory in Chile captured something extraordinary moving against the starfield. Larry Deneau, a key member of the Atlas survey team at the University of Hawaii, was conducting routine observations when the automated detection software flagged an unusual fast-moving object. The initial designation A11PL3Z was assigned to this mysterious visitor as astronomers worldwide scrambled to confirm its interstellar origin. John Tonry, the principal investigator of the Atlas project, immediately coordinated with observatories across the globe to track the object's trajectory and confirm its hyperbolic orbit. Within 48 hours of detection, follow-up observations revealed pre-discovery images dating back to June 14, 2025, indicating the object had been silently approaching our solar system for weeks. The challenge of detecting 3I Atlas stemmed from its path through the dense star fields near Sagittarius, where countless background stars made it nearly invisible against the crowded stellar backdrop. Once confirmed as an interstellar visitor, the Minor Planet Center officially designated it as 3Y Atlas, marking a historic moment in astronomy. This rapid confirmation process demonstrated the remarkable advancement in our ability to detect and track these rare cosmic messengers. A stranger in our midst. Alright, get ready to be amazed by the extraordinary characteristics that make 3I Atlas unlike any object we've ever studied in our solar system. This interstellar giant is racing through space at a mind-boggling 61 kilometers per second relative to our Sun, a velocity so extreme it actually proves the object originated from beyond our solar system's gravitational influence. Marco Michelli from the European Space Agency has determined that 3Y Atlas measures approximately 11.2 kilometers in diameter, making it significantly larger than both previous interstellar visitors combined. To put this massive scale in perspective, this cosmic wanderer is roughly the size of a small city, totally dwarfing the mysterious Oumuamua, which measured only about 400 meters in length. Daryl Seligman from Michigan State University pointed out that the object's brightness and size make it an unprecedented target for detailed scientific study. Unlike typical solar system objects that follow predictable elliptical orbits around the Sun, 3I Atlas follows a hyperbolic trajectory that will carry it back into the depths of interstellar space. The comet has developed a spectacular 25,000-kilometer-long tail as solar radiation heats its ancient ices, creating a magnificent display visible through powerful telescopes. This combination of extreme size, speed, and activity makes 3I Atlas a once-in-a-lifetime opportunity for astronomical research. The predecessors. To understand the true significance of 3I Atlas, we really need to look back at the groundbreaking discoveries that paved the way for this moment. The very first interstellar visitor, 1I Oumuamua, was discovered on October 19, 2017 by Robert Warwick using the Pan-STARRS 1 telescope in Hawaii. This cigar-shaped object, measuring roughly 400 meters long, totally baffled scientists with its unusual tumbling motion and mysterious acceleration that couldn't be explained by gravitational forces alone. Avi Loeb from Harvard University famously proposed that Oumuamua might be artificial in origin, sparking some pretty intense debate in the scientific community. 2 years later, amateur astronomer Gennady Borisov discovered 2Y Borisov on August 30, 2019 from his observatory in Crimea. Unlike the enigmatic Oumuamua, Borisov behaved like a typical comet, developing a coma and tail as it approached the sun. Alan Fitzsimmons from Queen's University Belfast led extensive spectroscopic studies that revealed Borisov's composition was remarkably similar to comets in our own solar system. These discoveries established that interstellar objects come in different varieties, some mysterious and unusual like Oumuamua, others more familiar like Borisov. The cosmic journey. So let's follow the incredible path this ancient wanderer will take as it sweeps through our solar system over the coming months. Davide Farnocchia from NASA's Jet Propulsion Laboratory has precisely calculated that 3Y Atlas will reach its closest approach to the Sun, called perihelion, on October 29, 2025 at exactly 11:41 Universal Time. At this critical moment, the comet will be positioned 1.36 astronomical units from the Sun, about 203 million kilometers away, perfectly situated between the orbits of Earth and Mars for optimal observation conditions. This cosmic dance includes several remarkable planetary encounters that provide unique scientific opportunities. On October 3, 2025, the comet will pass just 0.19 astronomical units from Mars, only 28 million kilometers away, potentially allowing Mars-based instruments to conduct unprecedented close-range observations. Following its solar encounter, 3Y Atlas will swing past Venus on November 3, 2025 at a distance of 0.65 astronomical units before beginning its journey back to interstellar space. Earth remains completely safe throughout this celestial ballet, with the closest approach occurring on December 19, 2025 at a comfortable distance of 1.8 astronomical units, or about 270 million kilometers. This trajectory provides astronomers with multiple observation windows and vantage points throughout the solar system, maximizing scientific opportunities. A scientific gold mine. The arrival of 3I Atlas represents, honestly, an unprecedented scientific opportunity that has mobilized the global astronomical community like never before. Karen Meach from the University of Hawaii is leading an international consortium of researchers conducting comprehensive studies of the comet's composition, structure, and behavior. The James Webb Space Telescope, under observations coordinated by Stephanie Milam from NASA Goddard Space Flight Center, has been scheduled to conduct detailed infrared spectroscopy to identify complex organic molecules within the comet's nucleus. Alan Fitzsimmons from Queen's University Belfast has already detected unusual isotopic ratios in the comet's gas emissions using the Gemini Observatory, suggesting formation conditions vastly different from our local environment. Ground-based facilities including the Very Large Telescope in Chile and the Keck Observatory in Hawaii are providing continuous monitoring of brightness changes and spectral evolution. Bin Yang from the European Southern Observatory has identified traces of exotic water vapor with unusual deuterium concentrations, indicating the comet formed in an extremely cold environment around a different type of star. This coordinated global campaign represents the most comprehensive study of an interstellar object ever conducted, with data collection providing insights into star formation processes, planetary system evolution, and the distribution of life-building molecules throughout our galaxy for decades to come. Unanswered questions. Despite intensive observations, 3I Atlas continues to harbor profound mysteries that challenge our understanding of interstellar objects and their origins. Quanji Ye from the University of Maryland has been tracking unexpected brightness variations that just don't match typical cometary behavior, suggesting the object may have an unusual internal structure or composition. The comet's reddish coloration, observed by multiple telescopes worldwide, indicates the presence of organic compounds, but the exact nature of these materials, well, it remains unknown. Matthew Knight from the Naval Research Laboratory has noted that high-resolution Hubble Space Telescope images reveal intricate details in the coma structure that don't conform to standard comet models. One of the most perplexing aspects is the object's estimated age of 7 billion years, older than our entire solar system, which really raises questions about how such ancient materials have remained preserved during eons of cosmic radiation exposure. Tony Farnham from the University of Maryland has documented irregular outgassing patterns that suggest complex subsurface processes we honestly don't fully understand. The Discovery team, led by Daryl Seligman, acknowledges that many fundamental questions remain unanswered. What star system did it originate from? What caused its ejection into interstellar space? And perhaps most intriguingly, could there be more to this object than meets the eye? These mysteries ensure that 3I Atlas will remain a subject of intense scientific scrutiny. The alien question. Here's where the discussion takes a fascinating and honestly controversial turn that has divided the scientific community. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University and former chair of the Astronomy Department, has gained international attention for suggesting that some interstellar objects might be artificial in origin. Following his controversial proposals about Oumuamua, Loeb has expressed interest in 3I Atlas, noting that its unusual characteristics warrant careful investigation of all possibilities, including artificial origins. Sarah Seeger from MIT has emphasized the importance of maintaining scientific rigor while remaining open to extraordinary possibilities, stating that we must examine every aspect of these rare visitors. The Galileo project, led by Loeb at Harvard, represents a systematic scientific approach to searching for evidence of extraterrestrial technology in our solar system. However, most mainstream astronomers, including Paul Chodas from NASA's Center for Near-Earth Object Studies, maintain that natural explanations can account for the observed properties of interstellar objects. Robert Warwick, discoverer of Oumuamua, has consistently argued that these objects, while unusual, fall within the expected range of natural cosmic phenomena. The debate really highlights the importance of maintaining scientific skepticism while remaining open to paradigm-shifting discoveries. Dawn of a new era. The discovery of 3I Atlas signals the beginning of a revolutionary era in astronomy, where interstellar objects will become regular subjects of scientific study rather than once-in-a-lifetime discoveries. Mark Norris from the University of Central Lancashire predicts that advancing technology will soon make these detections routine, fundamentally changing how we study galactic dynamics and planetary system formation. The Vera Rubin Observatory, which began full operations in 2025, is expected to revolutionize interstellar object discovery with its ability to scan the entire visible sky every few nights using advanced LSST camera technology. Michelle Bannister from the University of Canterbury estimates that within the next decade, we'll have discovered dozens of these cosmic wanderers, providing statistical samples large enough to understand their origins and distribution throughout the galaxy. Robert Yadika from the University of Hawaii calculates that the improved Atlas survey system, now operating telescopes in Hawaii, Chile, and South Africa, will detect several interstellar objects annually. This technological revolution means that each new discovery will add pieces to the cosmic puzzle of how materials, and potentially life itself, are distributed throughout our galaxy. The age of interstellar archaeology has officially begun, promising to unlock secrets about distant worlds and the formation of our cosmic neighborhood that have remained hidden for billions of years. From its mysterious origins billions of years ago to its spectacular journey through our solar system, 3I Atlas has challenged everything we thought we knew about interstellar visitors. Whether it's a natural cosmic wanderer or something more extraordinary remains to be discovered. As this ancient traveler continues its path back to the stars, It leaves behind more questions than answers, and opens our minds to possibilities we're only beginning to imagine. Like, share and subscribe to InnoVision Tech for more incredible discoveries from the cosmos.